Okay, I'm recording again. Okay, so let's say we have this race. So we have this race example. Okay, that is, you have 8 people who are running in a race. They're running, I guess, a mile. And in these kinds of races, usually if you finish first, you get the best prize. You finish second, you get something else, and so on. Well, let's say there are 8 people running. The one who finishes first gets the gold medal. Now, that's usually what happens. The one who finishes second doesn't get gold, they get a silver medal. The one who finishes third gets bronze. That's the bronze medal. Okay, so the question is, how many different ways can these 3 medals be awarded? Okay. Hopefully you can easily see that order does matter, right? The whole idea we're asking is, we have these 8 people, right? How many ways could we award the 3 medals is what we're asking. The person that comes first gets the gold. The person that comes second gets silver. The person that comes third gets the bronze. We're wondering, well, how many ways can that happen is what I'm saying, is what we're saying. So clearly order matters. Also, you can't finish first and second place, right? That doesn't make sense. So repetition is not allowed. So order matters, no repetition, be a permutation. There are 8 possibilities. N is 8. There are 8 people running, so there are 8 possible people that could get a medal. We're choosing 3 of them. We're working with 3, right? Because those 3 people are going to get the medal, so R is 3. So in other words, we want P of 8, 3, which turns out to be, by the formula, 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. I'm just using this formula here, which is equal to this. And of course, if you were to write this out, this is what you would get by what factorials are. Here, multiplication, it's associative. So I wrote parentheses here. And by cancellation, you get 8 times 7 times 6, which is this. Even looking at this calculation, it should make sense. The first, giving away the first gold medal, right? There are 8 people who could finish first, right? 8 possible people in that race. So that's 8. Someone finishes first, but then you have 7 people remaining that could finish second. So you have 7 possibilities here. And then once the first 2 people finish, you have 6 people remaining. And we multiply because of the basic counting rule. That's what we do. We just multiply that way. All right, that's cool. And now here I'm just saying, okay, what if there were 10 people here? It's the same idea, but instead of 8, we have 10. So N in this case would be 10. R is the same. So again, no repetition, order matters. So we have this. And that turns out to be 720. I don't know about the Android phone. I do know the iPhone, you could do factorials, but you can't, they don't have a P of N R feature in there. I don't think they do. I know Desmos does. That's what permutations, okay? All right, let's do another one. All right. All right, so here we're going to form a 4 4-person executive committee, right? And was selecting these 4 people from a 16-member board of directors of a nonprofit organization. We want to know how many ways that can be done. So that's the question, what they're asking. So one person's president, one is vice president, one is secretary, one is treasurer. I mean, no one can serve more than one role. You know, you can't be president and vice president. At least generally you can't. In theory, that is. So there's no repetition here. Order matters, of course. That should be kind of, I don't want to say it's obvious, but order does matter. First person you pick, they're president. The second person you pick is going to be vice president. Third person, secretary. You know, that's usually how they do these kinds of elections. Because of that, we have order matters, no repetition, without replacement, in other words. That's what without replacement means, no repetition. You know, once you pick something, you can't choose it again. So how many ways? P of 16, comma 4. There are 16 possibilities. We're choosing 4 for this purpose. We get this. That's what we get. As you can see also, the calculation kind of implies, well, this calculation should make sense, right? 16 for the first person, 16, excuse me, for the president, 16 possible people, someone's chosen, you have 15 people remaining for vice president. You have 14 people remaining for secretary and 13 people left for treasurer. So from the calculation alone, excuse me, from the calculation, it should make sense. You know, we're just multiplying by the basic counting rule. Okay. Are there any questions about that? I mean, I can't see the chat now, so use the hand raise feature if you have a question. If you don't, that's okay. Okay. Well, someone has a question. Yeah.
I don't understand why. It makes sense how that works, the 16 that then goes to 15 and 14, but why does multiplying all those numbers and then getting that big, what is that really doing? If that
It's
makes
telling
sense.
you how many ways we can make this 4-person committee. People. So there are 16 people, right?
But how, no, yeah, I get that, but how does multiplying those numbers, how does that, how does multiplying those 4 numbers get you that?
That's just from the basic counting rule.
Oh, so it's an equation? A formula?
Like a rule, you could say, or I guess a formula, but I guess in a sense it kind of is. So
if I were to Google oh, so there's not really a formula you'd follow?
Not really a formula, because what's happening is this. You have the basic counting rule, right? What happens is if you have a certain, if there are a certain number of ways, right, to complete the first task. And our first task here would be choosing a president out of the 16 people.
Mm-hmm.
And the next task would be choosing a vice president.
Right.
And that would be 15 ways, because there's one person, you know, someone can't serve both. Basic counting rule, you would have to multiply them, get the total number of ways.
Mm-hmm.
And then, okay, what about secretary? Well, there's 14 people left over. 14 ways the task of choosing a secretary can be done. So now you multiply by that. And then the same thing for treasurer. Does that help? Or
so could so this question says 4-person, but could that change, and then the 16 member?
Oh yeah, definitely. If I could reason we don't have a treasurer anymore, we only have 3 people, and it would be 16 times 15 times 14.
Okay, thank you so much. That
Does
makes
that
sense.
help? Or
Yeah, thank you.
sure?
Mm-hmm.
Okay.
Thank you.
I'm happy to help. Are there any other questions or? Again, it's just multiplying is all we're doing. I mean, I wouldn't want to write out all the possible outcomes because that would be 43,680. So that'd be a lot, right? But again, it's just multiplying is what it boils down to. You know, the number of ways of completing the first task times the number of ways of completing the second, and so on. I mean, the 4 here comes from a 4-person committee. So if there was another job made, let's say, I don't know, another job someone can do, I guess, I don't know, senator, let's say, and there's 5 people on the committee, then I would multiply by 12. There's 12 people left. So hope that helps a bit. I know this stuff's not easy, I know. I just really want everyone to understand it. So my goal, I said. But anyway, let's keep going.